Okay, so what we're going to talk about today is solving systems of equations that are nonlinear. All right, this is a jump in our book, up a couple chapters, and what we're going to do is use the same methods that we already learned for solving systems of equations. And one of those methods is by graphing, and we're going to do that not by hand, but on our Desmos app. We're also going to use substitution. And finally, we can use elimination. Whether we use substitution or elimination depends on what we have to work with. So let's just see what we've got here. So in my very first problem, I've got something with x squared and y squared, and here this has just plain x and y. This will be a line. So what I want to do is let's go ahead and graph this on Desmos, and I'll show you what this looks like. So we've got 4x squared plus y squared equals 25. And the other one is a line, 2x plus y equals -1. Okay? So here's what we've got. The green shape is something we call an ellipse. You probably think it looks like an oval. It's called an ellipse. And then we've got a purple line going through it. And what we can see from here is that we have 2 points of intersection. So when we go to do this problem, we know that we need to find 2 points of intersection. And if you just tap on it, it will bring up the points. So this is 1.5 or 3 halves and -4. And this one is -2, 3. So they're actually nice answers this time. So let's go ahead and go through this so you can see how you would do this algebraically. Now in this particular case, I think the best way to go about solving this is actually to do this with substitution, which means I either need to get x or y by itself. And here I can get y by itself by subtracting 2x from both sides. So what I have then is y equals -2x minus 1. And so what I want to do is I'm going to substitute that in the other equation. So what I'll get is I'll have 4x squared plus -2x minus 1 in parentheses squared. I put it in place of y equals 25. My next step here is I'm going to FOIL this. I need to FOIL this so I can combine all my like terms. So I've got 4x squared. When I FOIL this, -2x and -2x gives me plus 4x squared. I have -2x times -1 is positive 2x, double that because I'm going to do it 2 times. So plus 4x, and then -1 times -1 is plus 1 equals 25. All right, well, I'm going to have an x squared term. So if you recall from a while back, the way we're going to solve this is get everything on one side, have 0 on the other. So I'm going to subtract 25 from both sides. And I'm going to combine these, and I'll have 8x squared plus 4x minus 24 equals 0. And now I actually need to factor this. Always look for the easiest thing first, GCF. Let's take a 4 out of this so it's not so big. So take a 4 out, and this will give me 2x squared plus x minus 6 equals 0. And now I've got something that will work a little bit easier with the box. So I'm going to go ahead and draw a box. The 2 goes here, the -6 here. I need something that multiplies to -12 and adds to 1. So how about 4 and -3? My GCF here is 2. 2 times 1 is 2. 2 times 2 is 4. 1 times -3 is -3. So that gives me a 4, a 2x minus 3, and an x plus 2 equals 0. So out of this, I know 2x minus 3 equals 0, or x plus 2 equals 0. Add 3 to both sides, divide both sides by 2, and I get x equals 3 halves. Over here, subtract 2 on both sides, and I get x is negative 2. Now remember, when we're doing a problem like this, we're not done just because we found x. We've got to find the points. So we need to know the y's that go with each one of these x's. So I can go back to either equation. I find that the easiest thing for me to do is go back to this. All right? And I'm going to plug in my x's, and we'll calculate our y's. So I've got y equals negative 2 times 3 halves minus 1 equals negative 3 minus 1 equals negative 4. So this gives me the point 3 halves negative 4. Now let's do it again for x is negative 2. So y equals negative 2 times negative 2 minus 1 equals 4 minus 1 is 3. So our second point is negative 2, 3. And if we go back to our graph, right here, those were the 2 points that we already identified. So we did this algebraically as well as graphically. All right, so let's go to our next one. And this looks a little bit different. And I'm going to go ahead and we'll graph these and we'll see what we've got. So I've got x squared minus y squared equals 12. Oh, that's an interesting shape. I'll show you in a minute. And xy equals 8. Check this out. All right, the orange one was the first equation. That is actually called a hyperbola. All right. The second one here is I don't know what you would call this thing. It's actually a rational expression, because if you got y by itself, it would be x over 8. So it's a rational expression, or 8 over x. It would be a rational expression. But you can see our points of intersection are here and here. So those are the 2 points we've got to find algebraically. Okay, so we probably want to use substitution here. And I need either x or y by itself. I'm just going to get y by itself by dividing both sides by x. So here's what I've got. I've got y equals 8 over x. And I'm going to substitute that in that first equation. So I've got, let's see, x squared minus 8 over x quantity squared equals 12. Alright, that gives me x squared minus 64 over x squared equals 12. And actually what we've given ourselves here is something we're studying right now, a rational equation. And recall that the way that we solve a rational equation, multiplying both sides by the LCD, which is x squared. And now we know also x cannot equal 0, right? Because x is in the denominator. Let's write that down. X cannot equal 0. So let's go ahead and distribute. This will give us x to the 4th minus, when we bring that x squared over to here, notice you'll have 64x squared over x squared, and the x squareds just cancel, so you have 64. And this equals 12x squared. All right, let's get everything on one side. So I've got to subtract 12x squared on both sides. and I've got x to the fourth minus 12x squared minus 64 equals 0. And presumably I'm going to need to factor this. So I'm looking for what multiplies to negative 64 and adds to negative 12. And I'm thinking 16 and 4. So this would be x squared minus 16 and x squared plus 4. So here's what I know. Either x squared minus 16 is 0, or x squared plus 4 is 0. All right, looks like this is going to give us 4 solutions, doesn't it? Here, if you add 16 to both sides, you have x squared equals 16. And when you square root, you get to the point where you have x equals plus or minus 4. Because remember, when you square root both sides, you get 2 solutions. But if you notice, we've got x squared plus 4 is 0. When you subtract 4 on both sides, you've got x squared equals negative 4. And when you square root both sides, this is imaginary. That's not going to give you a real solution. So it's not going to give you something on your graph. Therefore, you're just going to leave it alone. We're not going to use it. We're only going to use plus and minus 4. All right? The next thing we've got to do is go back and we've got to solve for y. And you know what I'm going to use? This. Y equals 8 over x. So first of all, I've got y equals 8 over 4. And that equals 2. So I have the point 4, 2. The other one is negative 4. So I have y equals 8 over negative 4, which gives me negative 2, which is the point negative 4, negative 2. And if we go take a peek back at our graph, we see those are the exact points that we have highlighted. All right, let's go to the next one. All right, in this particular case, guess what we can use this time? We can actually use elimination. The reason why is, look, we have like terms in both of our equations. So something that we could do, one option, is take the second equation and multiply it by 2. Leave our first equation alone, so x squared plus 2y squared equals 23. And then the second one, when I multiply it by 2, is 4x squared minus 2y squared equals 2. And now when I add them, my y squareds eliminate, and I have 5x squared equals 25. Let's go ahead and divide both sides by 5. And we have x squared equals 5. Let's take the square root of both sides. And this would give us x equals plus or minus the square root of 5. Now let's take a second and we'll go ahead and graph this so we can see what we're even looking at. So first of all, we have x squared plus 2y squared equals 23, which gives us a nice ellipse. And then we've got 2x squared minus y squared equals 1. And that gave us a hyperbola. So we have an ellipse and a hyperbola. And if you notice, we've got 4 points of intersection here. So I'm going to try and highlight them all. And let me just guess, that 2.236, I bet is the square root of 5. See? It is. All right, so we're on the right track. So we've got to find 4. Let's see if we can get 4 out of this. All right, the next thing I need to do is I actually need to solve for y. So I've got to go back to one of these equations and I've got to solve for y. If I just take a look at this second equation here, if I wanted to get y by itself, one thing I could do is add y squared on both sides and subtract 1 on both sides, and I would get 2x squared minus 1 equals y squared. I can use that, all right? So I'm going to plug this in here. I'm going to first, well actually it won't even matter. If I put in a negative square root of 5 or a positive square root of 5 in here, guess what? I get the same thing either way, right? So what I get out of this goes with both the 5 and both the square root of 5 and the negative square root of 5. So 2, we'll put plus or minus square root of 5 squared minus 1 is y squared. So this turns out to be 5 times 2 is 10 minus 1 is y squared. So 9 is y squared. Square root both sides, and again that gives you y equals plus or minus 3. This is how we get 4 points. All right, first start with square root of 5. We have a 3 with it and a negative 3 with it. Because if you put in positive square root of 5, you get both of these answers. If you put in negative square root of 5, you get both of these answers. So also, negative square root of 5, 3, and negative square root of 5, negative 3. And let's take a look at the graph again. And that's exactly what we've got. This is why using your Desmos while you're doing this is really helpful. Keeps you on track. All right, one last problem to go through. And again, notice we have like terms, so we can use elimination. I might, for example, take the top one and multiply it by negative 3. So I get negative 3x squared minus 3y squared equals negative 21, and on the bottom I have 4x squared plus 3y squared equals 24. The y squareds eliminate, and I have x squared equals 3. Square root both sides, and I get x equals plus or minus the square root of 3. All right, let's put these in and see what we have. So first of all, I've got x squared plus y squared equals 7. And then I've got 4x squared plus 3y squared equals 24. This is really going to be hard to see. The green one is the first equation, and it is a circle. All right? The purple one is the second equation, and it is an ellipse. It's more oval shaped. So notice there's 1, 2, 3, 4 points of intersection. And guess, if I had to guess, I'd say 1.732 is the square root of 3 that we just found. And you'll notice it is. So we're on the right track. So now we've got to solve for y. So I would take this first equation and just subtract x squared from both sides, and I get y squared equals 7 minus x squared. And here's what I got to do. I've got to put this in here. And notice once again, since I'm squaring this x, I'm going to get the same answer whether I put in a positive square root of 3 or a negative square root of 3. So y squared equals 7 minus plus or minus square root of 3 squared. So 7 minus 3 equals 4. And I've got y squared equals 4, square root both sides, and I get y equals plus or minus 2. So let's go back and name all our points. So if I have square root of 3, I get a 2 with it. Square root of 3, I also get a negative 2 with it. Negative square root of 3, I get a 2 with it. Negative square root of 3, I get a negative 2 with it.